Good evening, my dear students. Today I am going to discuss about the trajectory plan. Okay. In today's class, I am going to explain about the trajectory planning. What is the trajectory planning? Okay. So, in the trajectory plan, we already seen that the robot manipulator have to perform different movements. Okay. For example, it may be a material handling robot or it may be a some manufacturing processing robot. Okay, whether it is a manufacturing processing robot or whether it is a material handling robot, the robot have to perform different movements. Okay, and to perform the job and during the operation, that manipulator have to move to the target point. That is, for example, I want to make the robot arm to perform certain welding operation. So that robot arm or that gripper or that robotic manipulator should reach the object to perform the uh, that welding task in a proper way. So for that, no, we have to plan the trajectory. So during that, because I should not to perform that welding operation, that uh, arm have to move in particular direction to perform the joint. Maybe that joint, that welding joint, maybe lap joint or butt joint, whatever the joint. Okay, to perform that intended operation. Okay, that upper robot should arm should move in the particular path. So for that, and also it should reach to the the particular target point with the best possible time and should not cause any collisions. Okay, for example, see in this particular diagram. Okay, so it should move from initial position to the final position via intermediate points within the specified duration of the time subject to the constraints. Okay, so in the trajectory, what in the trajectory planning, we are moving the robotic arm from one position to the other position, that initial position to the final position via intermediate points within specified duration and with the certain constraints. Okay, for example, you see that in this particular diagram. Okay, that robotic this particular manipulator is like two finger mechanical gripper. Yeah, they are used here. So this particular gripper and manipulator is holding the object. You can see circular object here. So this is the like initial position. Okay, you can see that one particular position, and after that it is moving with some intermediate positions points like a dash, b, a double dash, and b, c double dash, c dash, and final point is the c. So it have to reach to the point C, and during that one constant I'm telling that in between the A and C, you can see that there is a one object is there, this particular cylindrical object. So that particular robotic manipulate arm should not hit this particular object. It should not it should, without hitting this particular object, it have to reach from point A to point C. So that type of uh, like, planning planning the movement of the robot, we call it as the trajectory planning, moving from initial position to the final position via intermediate points within the specified duration of time, and should have the certain because you have to make that your robot arm within that it may, for example, from A to C, it may you may that operator may have that idea that it may take some 1 minute or 2 minutes, like that. Within that time only you have to make that a robot manipulator to move from point A to C. That's why always the trajectory planning is moving from initial position to the final position via intermediate points within the specified duration of time subjected to the different constraints. That is the trajectory planning. Okay. Okay. So next, what is the path and trajectory planning? What is the difference between the path and trajectory planning? Okay. The path is only geometric considerations. Okay. The way it is go from uh, point A to point B. Okay, that is the path. Okay, path just only is we have to specify the different movements like a x position, what is the y position, what is the z position. For that, whether we have to perform the translation movement, that is linear movements, whether for that we have to perform rotation movements, what different things. Okay, only where we have to make the robot to move from different points. Okay, so we are not specifying any time constraint. That is one of the path. But in the trajectory planning, okay, we are having like including the it we have to make that robot manipulator to perform the task within the certain time. So where you are planning that make the robotic manipulator to move from one position to other position via intermediate points within the specified time, that comes under the trajectory planning. Okay. So in path planning, what like different inputs we have to give. Okay, because whatever the like robotic manipulator that it have to perform different movements. Okay, it requires the details. Okay, what about the object, what type of object that a robot have to perform it operation. Okay, and surrounding location, all these details also we have to give the requirements. Okay, and during that path planning, okay, path planning, we have to decide what type of movements that the robotic manipulator have to perform to as per the geometric details related to the object. Okay, for that what is the initial the configuration of the robot. We already discussed different types of robot configurations. Okay, as per that, whether you are using a like tribular type of robot, or that is tribular means three rotational joint related robotic arm, whether you are using two linear movement and one rotation, what type of robotic configuration. Okay, based on that uh, and what type of movements that are possibly required, such a way that the object that robotic arm can perform different movements as per the requirements. It can perform such a different movements can be performed such a way that the intended output can be done. Okay, so based on the output, so whether you are gripping that it is a material handling robot or some processing robot, what is the output? Okay, well, based on that will based on the shape and based on the robotic configuration will plan the what type of movements that have to perform. To perform that, what type of movements we have to perform, that movement should be within the limit of that robotic configuration. Okay, whether if it is entire your robot is having all three linear joints, within that constraints of like a linear robotic configuration, you have to plan the path. Okay, so after that you will plan and you will execute the like program, or you may use some teach pendant, or you can give some program to the robot. Accordingly the robot will perform, and because you already planned such a way that without any collisions the robot movements will perform. That's why that robot will perform different continuous movements, and without collision free you can the robot will perform, and as per the configuration it will makes that different movements such a way that it may reach to the its final position. That's how we have to do the path planning. Okay. And in the trajectory planning, already mentioned that, because in the like path planning only will see about the that position, like to what is the different x moment, y moment, and z moment, what is the configuration of our particular robot. Okay, based on that we have to decide the our what type of like movements it will perform. Based on that we can give the input, and accordingly you can program. And in the dynamic part, where based on the like you should reach that robot should reach to the uh, point A to point C without any collision. For that, within the you know uh, like 2 minutes or 5 minutes, the time sequence. So exactly we have to plan. So within that time, because always in manufacturing sector or material handling sector, that there is a lead time is one of the important thing, where within the time that all tasks should be performed. So we have it in proper way that the robot should perform all these tasks uh, within the given time slots. So as per the like operator, he will based on the like type of operation, and he will like determine the appropriate time, and accordingly will plan the trajectory planning. And finally the robot will reach to the that as per the given constraints, like given kinematic model, that is where kinematic model we already discussed that different linear moments, rotational moments will specify. Okay. And different things will specify accordingly under dynamic input, like within that time constraints also have to plan, and accordingly the robot will perform the different no, movements it will perform. Okay. So what are the steps in the trajectory planning? Mainly there are three different steps are there. One is the task description, and second one is the selecting and employing a trajectory planning technique, and after one is the computing the trajectory. These are the important steps in the trajectory planning: task description, selecting and employing a trajectory planning technique, and computing trajectory. The first one is the trajectory planning task description, in the where the based on the requirement, whether what is the like we have to decide what type of robotic motion we have to perform, whether it is a point to point operation, or whether it is a continuous path, or whether it is a more than different points where the robot have to move. Based on that requirement, we have to identify what is the different types of movements are required that are coming in our task, that we have to identify, whether it is a point to point motion, or whether it is a continuous path motion, or whether it is a more than different 2 points are coming in the path. And next one is the like trajectory planning, selecting and employing a appropriate trajectory planning technique. So whether we have to use a giant space technique, or whether we have to use a Cartesian space planning technique, that we have to use. Okay. We already discussed that what is the giant space technique and what is the Cartesian space planning technique. So we have to decide. So what type of this particular technique, whether we have to use the giant space techniques, or whether we have to use the Cartesian space planning technique, that we have to decide. Especially in the giant space techniques, in the giant space trajectory planning, each path point is specified in terms of the desired path and orientation of the end effector frame to the relative base frame. Especially in the giant space trajectory planning, each path point is specified in terms of the desired position and orientation of the end effector frame to relative base frame. Okay, we already discussed in the forward kinematics. Okay, so most probably we are specifying the desired position orientation. The end effector frame, that is the gripper position or related tool position frame, always we are specifying related to the base frame. So especially in giant place technique, the end effector position will be specified with respect to the base frame, that is uh, zero frame. We seen different frames, how we are going to assign the frames, all these things in earlier classes. So accordingly, we have to decide whether this particular giant space technique. So each of these points is converted into a set of desired point position by application of inverse kinematics. Okay, because once after you this particular technique, after that each of these particular points is converted to the desired point giant positions by the application of the inverse kinematics. Okay. Other technique is the Cartesian space planning technique. In Cartesian space planning, the path is specified in the Cartesian space. In the Cartesian space planning, the path is specified in the Cartesian space. That is, the path constraints are specified in the Cartesian coordinates, and the giant actuators are served in coordinates to the specified trajectory. Okay, because the path constraints are specified in this particular Cartesian coordinates, and giant actuators are served in coordinates to this particular specified trajectory. So this is how the difference you can see that between this Cartesian scheme and giant space scheme. Okay, especially in this particular diagram, S is denotes the initial position. Okay, this one is the initial position, and F is the final position. Okay, and these 1, 2, 3 are the intermediate points. Okay, this is the starting, the initial position, then S21 and 1 to 2 and 2 to 3 and 3 to G. That is G is the final position. Okay. In the case of Cartesian scheme, the we'll specify a starting point like is xs and ys. Okay, and in because we are using the x and y coordinates. Okay, for to describe entire this starting point, like first point, second point, third point, and G point. In the case of a giant space technique, okay, we are going to specify the related to the like base frame, like we are going to 1 to s, 2 to s. Okay, okay, that 1 to 1, 2 to 1, 1 to 2, 2 to 2, 1 to 3, because you can see that entire this theta is suffix we are indicating as 1. 1 is related to the here frame 1. Okay, frame 1 to yes, frame 2 to yes, frame 1 to 1, frame 2 to 1, frame 1 to 2. Okay, like that, frame 2 to frame, that is 2 to 2, and frame 1 to 3, frame 2 to 3, frame 1 to G, frame 2 to G. Like that we are going to specify in the case of the giant space scheme. Okay, so these are the differences between the Cartesian space scheme and giant space scheme. Yeah, it is where we are going to describe the motion, the task in by means of the space coordinates. But in the case of giant space scheme, here we are specifying the giant angle values. In the motion between 2 points is known all the times and controllable. Okay, especially in the Cartesian space, we are using the space coordinate. That's why always the motion between 2 points is known at all the times and controllable. Used for point to point type of motions. Particular giant space scheme is used for the point to points motion, and this is easy to visualize and the trajectory. It's Cartesian space scheme is very easy to visualize the trajectory. This giant space scheme, first and second order derivatives must be continuous. Okay, and like if any obstacles in the, there will be possibility if you are using this Cartesian space scheme, it accounts the obstacles in the workspace. This does not account the for the obstacles. That is the comparison between the Cartesian space scheme and giant space scheme. And this Cartesian space scheme is the like inverse kinematic problem we already discussed. Okay, how to do the inverse kinematic problem. And giant space scheme is like we will obtain the giant variables for each point by inverse kinematics or by teaching by showing the technique. Okay, sometimes that is teach pendant, that is teaching by showing techniques also can use to get the giant variables. Okay, and this computational is very complex in case of Cartesian space technique when compared to the giant space technique. And this Cartesian space scheme reduces the trajectory and sampling rate in real-time operation. That is the like comparison when we comparing this particular Cartesian space scheme with the giant space scheme. And this Cartesian space scheme is like trajectory tracking accuracy is somewhat decreases. Okay, and there are problems with the singularity in the case of Cartesian space scheme. In the giant space scheme, there is a non-linear nature related to the manipulator's kinematic model. This is a non-linear nature of a model where we are specifying the giant variables for each point. Okay, by means of inverse kinematic. Sometimes can find out the giant variables by means of the like a teach pendant or teaching by showing technique also. So in the track, next one is the we are going to perform the trajectory planning. So in this given end effector position, okay, find the like for the given end effector position, find the giant angles, because if you know the end effector position, because to reach that end effector position, the giant have to perform certain movements. For that, you have to find out the joint angles. Okay, and this fix a trajectory where we have to fix the trajectory to the end effector. That we can do in the two ways. That is fixing the trajectory to the end effector, and it has to follow the trajectory. Don't worry about the giants always. Okay. First, fix the trajectory. You just assuming that we are fixing the trajectory at the end effector. Okay, and plan at the giant level, that is each giant to try to fit the trajectory at the each joint, and after that performing the computing the trajectory. This is the final step in the trajectory planning. The final step is to compute the time sequence of values attained by the functions generated by from the trajectory planning technique. So main thing is the final step is to we have to compute the time sequence of values that are attained by the functions generated from the trajectory planning technique. Then these values are computed at a particular path update, because every the path will be updated in real time, that is in that frequency lies in the range of 20 Hz to 200 Hz. That is the sampling rate that actually the range it may happen in the range of 20 Hz to 200 Hz. In that most probably will observe in the different manipulators that we'll see in the industries. That's about how this trajectory planning. Okay, that's it for related to the trajectory plan. Today class I just discussed about the what is the path planning. Okay, what is the trajectory planning and what are the steps in the trajectory planning. Thank you students for coming and listening to my class. Thank you all.